be delivering a talk on Schwinger source theory, distributing the backward. That is it.
Disturbing the vacuum.
Yeah, disturbing the backward. Okay. So he did his BSc in Physics Honors from St. Xavier's College, Kolkata, and MSc Physics and PhD from this center. He was a postdoctoral fellow in National Institute for Theoretical Physics, Stellenbosch University, South Africa, from 2008 to 2009. Then he was a faculty in Department of Physics, West Bengal State University, Barashat, from 2009 to 2016, and also was a visiting academic in National Institute for Theoretical Physics, Stellenbosch University, South Africa, for a period of 1 year, from July 2013 to June 2014. Before joining this institute, he was an assistant professor in ISA, Kolkata. He joined this institute in 2017 and now is a professor in this theoretical physics unit. His research interests include applications of gauge gravity correspondence to strongly coupled systems, non-commutative quantum mechanics and quantum field theory, generalized uncertainty principle, and black hole thermodynamics. He is also a visiting associate in IOCA Pune since 2011. He was one of the convener of this ongoing program in previous years. So now the stage is all yours.
Detailed introduction. So thank you so much, and thank you the organizers of IEPT for giving me this talk and also in my convenient time. Thank you so much. And before I start, I just came to know that Obiru, who was the earlier speaker, is a friend of, very close friend of mine, Dr. Anirban Shah, who is in Barashat. And so we are also friends, and he also passed of the same college, St. Xavier's College. Just I was a year senior to him, to Udu. And we also found out that we live in the same places in Behala. So there is a big connection. And thank you, Udu, for a very nice talk that you gave. I learned a lot of things from the earlier talk. So this talk, this is not going to be a talk. This is going to be a class. So I would request all the students to take your notebooks out and write things up. So there will be a lot of calculations. So I apologize to all the students because of these calculations. Some I will try to be pedagogic as far as possible to show you all the details of the calculations. But still, since you are in BSc third year or MSc first year, some of the things may be a little bit difficult for you to understand, but I will try my best to tell you all the details. So the title of my talk is, as you have seen, that it is Schwinger's source theory, disturbing the vacuum. So I would just, before I start my talk, I would just like to ask, how many of you have heard of Schwinger, Julian Schwinger? Heard of Julian Schwinger? So do you have any information about him?
Yeah, he was very prominent in the field of quantum field theory. He had very out-of-the-box ideas, especially during the time when strong interactions were coming up. And this was one of the ideas, basically.
You are more or less right. So Julian Schwinger, he was a very prominent theoretical physicist, and he won the Nobel Prize in 1965 along with Richard Feynman and Tomonaga for quantum electrodynamics. And quantum electrodynamics is supposed to be one of the most accurate theories that physicists have developed so far, because it has been experimentally tested to a very, very good high precision, to 8 digits after the decimal place of a certain particular quantity. So that was calculated by Julian Schwinger. Julian Schwinger actually calculated the thing first. Feynman calculated it later, and nobody knew about Tomonaga because he was in Japan at the time when these calculations were being carried out, and the World War was going on. Later, people found that Tomonaga also did similar calculations, but Schwinger was the first to do that particular calculation to show that you can really calculate the anomalous magnetic moment of the electron to at least first order in perturbation theory. So he is the first person to develop the perturbation theory in quantum field theory or quantum electrodynamics, and also show that quantum electrodynamics is renormalizable to first order. So these terms, renormalizable and these kind of things, may go a little bit, you may not understand now, but we shall not deal with these things. But what you should know is that he did a quantum field theory which is known as quantum electrodynamics, and that was tested experimentally, and that is why he won the Nobel Prize in 1965. Another thing that he did is known as, he did many things. You will find Schwinger's name in many places, but one of the very beautiful things that he did, which is not taught at all to MSc students, there is no question of teaching this thing, is source theory. Something called source theory, Schwinger's source theory. And it is a very beautiful way, and also when he calculated this anomalous magnetic moment of the electron, Schwinger was completely against using Feynman diagrams. He never used Feynman diagrams in his calculations. He did everything by source theory. That is something very beautiful. And you know, Schwinger was a quantum field theorist, and quantum field theory basically deals with particles, with motions of particles and how they interact among themselves, how they decay, and many other things. So he did everything with this source theory, and it is unfortunate that particle physicists completely ignore Schwinger's source theory. But you will find in the library, if you go to the Essenbus library and also many other libraries, that he wrote 3 volumes of books on the references particles. You can write the reference particles, sources, and fields. Volumes 1, 2, and 3 by Julian Schwinger. And these 3 books, these 3 volumes, is an alternative way of understanding quantum field theory through source theory. So let us understand what source theory really is. So if we start with quantum field theory, or if you want to deal with the problem of particles, the basic thing that one wants to understand is the amplitude of any quantum mechanical process. You can see this font, right? This font is visible to you. So the amplitude of any process can be written in the following form. Any quantum mechanical process where you have a scattering process or something like that, you want to calculate the quantum mechanical amplitude for that process, and you will find that that amplitude is basically given by something C at x1, then G x2 semicolon x1, and then D semicolon is D function of x2. So what does that mean? It means that there is some creation process. The creation process, this is the creation amplitude. The creation is taking place at x1, and then the particle is propagating from x1 to x2, and then the particle is getting detected or destroyed. Detection is the process of destroying the particle. It is getting detected at the point x2. So this is a generic way of writing any amplitude of any process: creation, propagation, creation of the particle, propagation of the particle in space-time, and then detection of the particle at a certain point. This is the generic way of understanding any amplitude process. Now, in standard quantum field theory, what we do, if you try to analyze in a quantum field theoretical way, you have to understand how do we create particles. This is the first thing that we should understand. How do we create particles? So the standard way of creating particles in quantum field theory, suppose I want to create a single particle at the point x1, right? So in this lecture, I will just assume some prerequisites from the students. I'll assume that you know this kind of a notation. This is a Kate notation. How many of you know Kate and bra notation? You have know everything. So I really did not have any understanding of what Kates and bras, even what quantum mechanics is at the BSc level. But now you are very advanced. So it's very, very nice.
No, there was a course. There was a course. Part two.
Part two আমাদের Kate bras.
ওদের আমরা ওদের কেটটা বেশি পড়ি
BSc তে ছিল English.
না এখন ওদের অনেক বেশি আছে এখন ওদের লিনিয়ার ভেক্টর স্পেসও আছে
So that is very good. So that makes my life easier now. So you understand what this is. This is a Kate and this is a state. Okay. And this state is a vacuum state. Means it has no particles. Vacuum state means no particle state. And in quantum field theory, what you do, you have a quantum field theoretical operator. So any operator, you know that you have to put hats. I did not put the hat, but now I put it. So this is a creation operator in quantum field theory. So when it acts on this vacuum state, which is a no particle state, it will create one particle at the point x1. And similarly, you can have a destruction operator also in quantum field theory. When it acts on the vacuum state, it will destroy the vacuum completely. There will be no state. So what it means is, you must have seen this thing also. In harmonic oscillator, you have solved by algebraic method. So this is the annihilation operator in harmonic oscillator, and this is a vacuum state. So this will be zero. So this is also you are familiar with. These things you are familiar with. But the question is that, so this is a quantum field theory. This field theoretical operator is a way of creating particles from the no particle state. But what Schwinger does now, he doesn't go to quantum field theory at all. He assumes that there are no quantum fields. So start with, just forget about quantum fields. So that is a good news for you because you people are not aware of quantum field theory. So you don't need to know what quantum field theory is. So you forget about all this. So you say that there is some source J. There is some source J which is responsible for creating the particles. That is why source theory. So this is an external source, and this is something. So this is quite very physical, right? You all to have light in this room, you need some source. You switch on the source and you get light, right? So this is some source which is responsible for creating particles. So you assume no quantum fields for creating particles or destroying particles. You just assume that there is a source which is responsible for creating and destroying particles. This is the basic assumption with which Schwinger starts with. And
This is a C number or a quantum number?
this is
just a number or
this
something.
is a good question. Let me just say that this is a C number. This is not an operator. This is not an operator. So you don't need any operatorial algebra also. You don't need to. In quantum mechanics, we are dealing with operators. You don't need to deal with operators. This is a C number. It's an ordinary number, and this is some source, external source, which is responsible for creating the particles. And now I shall introduce one thing. I mean, শুনেছি আপনার প্রশ্নটা। This is also a very good question. To start with, this is a real number. The beautyটা হচ্ছে যে as আপনি ওটাকে you can actually take it to be a complex number also, and then the consequences will be different. If you take it to be a real number, the consequences will be different. It will create particles without charge. যদি সোর্সটা একটা কমপ্লেক্স নাম্বার হয়, it will create particles with charge. তার মানে in hindsight, you can actually understand that if you start with a real source, the J being a real number, it is going to create particles without charge. So it is in some way linked with a quantum field, which is a real scalar field. But if this is a complex number, then it is in some way related with a complex scalar field. So অঙ্কটা পুরো বেরিয়ে আসবে, স্মুথলি বেরিয়ে আসবে. So this is so just you can take it in your notebooks that this is to start with. It's a real number. It's a real function. It's something important.
মানে সি টার্মটা ক্রিয়েশনের সঙ্গে যুক্ত নাকি মানে সি টার্মটাকে সি নাম্বার কেন বলা
C number কারণ এখানে আমি কোনো অপারেটর ধরছি না, নো অপারেটর
ক্লাসিক্যাল থেকে সি এসছে
C number মানে হচ্ছে অর্ডিনারি নাম্বার, অর্ডিনারি কমিউটিং নাম্বারস। সি নাম্বারের অরিজিন এটা হচ্ছে নমেনক্লেচারটা হচ্ছে অর্ডিনারি কমিউটিং নাম্বার, মানে 2 3 5 এরকম কমিউটিং অর্ডিনারি কমিউটিং নাম্বার। Q number গুলো হচ্ছে operators. This is not an operator. And there is another kind of number. So since this topic is there, it's called Grassmannian number, which we are not fermionic numbers. They are also numbers, but with very weird properties. We don't need to. সেটাও এখানে করলে সেটাও করা যাবে. So everything can be done in Schwinger's thing. So the next thing that I shall start with, I shall assume is the following thing. এটার মানে কি? I shall introduce some amplitude. This is basically by definition I shall tell that this is I jp. J function of x is a real number, right? Now this is my basic building block. Schwinger starts with this. What is this? This is the amplitude for the creation of a one particle state. Amplitude for the creation of a one particle state. Please write it down. Everyone write all these things down. This is very important. This is the amplitude for the creation of a one particle state. One particle. একটা particle তৈরি হচ্ছে সেই probability amplitude টা কত? এই এখন আমি ব্রাটা ইউজ করেছি, কেট ইউজ করেছি না, ব্রা ইউজ করছি। In the presence of an external source from a no particle state টা কি? 0 minus. What does this mean? This basically means 0 at minus infinity. From a no particle state at t is equal to minus infinity. When t is equal to minus infinity, there was a no particle state, and from that state you are coming to a one particle state. So suppose j is equal to 0. What should this be? 0. কারণ এটা তো কোনো 0 particle and one particle, by orthogonality of states it should be 0. So one particle তৈরি হচ্ছে মানে the source is responsible for that. The source is definitely responsible for creating a one particle state. Someone must be responsible for creating something, right? If there is no something, then someone will not be created. So this is the amplitude for the process, and I define this tinted h in the matrix by definition. I define it to be I j times p, j function of p. Is that clear? This is my definition.
Is the I complex here?
I is a complex number. I is square root of -1. And you can also understand, since jx is real, it has Fourier transform jp. This is a complex number. This is a complex number. This is not a real number. jp is a complex number. Has to be. That you can show. I will show it. Fine. So this is basically Julian Schwinger's only building block.
Just a moment. I mean, this P, I mean, denoting particle
Ah,
and
P time
momentum, maybe say confusion.
This I should. Now I shall assume some special theory of relativity. So what kind of particles they are creating? So creating a one particle state with momentum p, but that momentum is a 4 momentum p mu, and that is basically omega p vector. I mean 3 plus 1 dimensional space time ei achi, not d plus 1 higher dimension, no string theory, no higher dimensions, nothing. 3 plus 1 dimension. Okay, this is a 4 momentum, and this is omega p vector. What does that mean? This is a 4 momentum which is on shell. So let me just write it down. On shell or mass shell. It is just a word that is used in QFT or in relativistic quantum mechanics. This is 4 momentum, right? Mu, this index takes values from 0, 1, 2, 3. Special theory of relativity সবাই জানে, right? Everyone knows special theory of relativity. And what I shall assume is, let me fix my notation first. Mostly negative signature. এই নোটেশনটা সবাই ক্লিয়ার? It basically means that this is a diagonal of this. মানে এটা যদি আমি পেড়ে লিখি বড় করে, তাহলে এটা হবে 1 -1 -1 -1 আর সব 0. Clear? So this is what eta mu nu is. So we are in flat Minkowski space-time. Flat Minkowski space-time. আর অন শেল মানে কি? এই পি মিউটা বেসিক্যালি হচ্ছে p0 and pi, where I is 1 2 3. সেটাকেই I've written it in short as 3 vector. p0 and pi here are independent components. They are independent, completely independent. But when I say on shell, তার মানে হচ্ছে এই p0 and pi are related. So I call p0 to be now omega p, and this is related to this p or pi in the following way: p square plus m square. All of you know this dispersion relation, right? Special variability. So what this external source is doing is that it is creating a one particle state which has this kind of a momentum. So where its energy, the zeroth component of the 4 momentum is energy, and these components are the momentum, right? Momentum in x, y, z directions. They are related by this dispersion relation. That is what I mean by on-shell 4 momentum. So zero component is not independent of this, rather it is dependent on this, on the 3 components. Okay, these kind of particles are being created by this external source J, and this is not my assumption, this is Schwinger's assumption, which he starts with. So if you start with this, now you can ask, so this is the basic building block. Now you can ask the question that what is this thing?
Annihilation of the created particles.
So you have a way of creating particle. So you look at this equation, you know how to create particles. You should know a way how to destroy particles also. Propagation e pore asbe. Come to this later. So let us know, understand how to destroy particles. So in order to understand how to destroy particles, you have to ask the question that if you start with a one particle state, then what is the amplitude of this one particle state going to a no particle state at the future? Okay, so at t, so this 0 plus basically means this is basically 0 at plus infinity. This is time, t going to plus infinity. Okay, this was early time, this is late time. In the presence of an external source, you need to understand what this amplitude is. And it will turn out that we shall show that this is basically equal to I J star P. Once again, this P is 4 momentum, but the 0th component is related to the 3 component by this relation. So it is on shell. এই রিলেশনটাকেই বলা হয় অন শেল বা মাস শেল, মানে 0th কম্পোনেন্টটা মাসের উপরে বসে আছে, মাসের সাথে রিলেটেড হয়ে বসে আছে। দ্যাট ইজ বাই অন শেল বা মাস শেল। ইজ দ্যাট ক্লিয়ার? এই অবধি ক্লিয়ার আছে সবাই? 0 প্লাস স্টেট গুলো 0 মাইনাস গুলো ক্লিয়ার আছে? So let us try, and this is my only assumption.
Sir, what is this one particle basis? Is it a complete basis in this theory that we are using?
Yes, yes, it is a basis. It is not a complete basis because you can create 2 particles, 3 particles, infinitely many particles. But I shall now prove this result. That if you assume this for the creation, then for the destruction, the relation has to be this. Let us prove this now. So proof. This is the first proof that we shall now do. This is a very important proof, and as you have correctly mentioned about completeness, completeness will come in this proof. So in order to prove this, let us start from this particular thing. Let us start from 1p. This is equal to, what do you think this should be equal to? It at a one particle state, it at a 0 particle, no particle state, no particles, but at minus infinity, but this is a graph at j is equal to 0. So what do you think this should be? It should be 0 because there is no source. Source is 0. So we start from this relation. So this is the orthogonality relation of 2 states. Now what we shall do is the following.
Assume the vacuum is
Yes, just let me write this equation and then I will explain.
this is
Completeness, let us forget about completeness. Let us try to understand the second line of the equation. The first line is clear, right, to everyone? Let us understand the second line of this equation physically. So what can happen from the one particle state? You can basically, you want to go this state. You want to go to this state, right? No particle state. So from the one particle state, you can go to a zero particle state at plus infinity. And then zero particle state সেটাই আছে, zero particle state to zero minus. This can be one of the processes that can happen. But on the other hand, you can go to from a one particle state to a one particle different momentum state q, and sum over all q, all different q's. But all these q's are once again on shape. You can go from the one particle state to a one particle state, but with a different momentum q. And from the one particle state with a different momentum q, you can come to zero particle state at minus this. But all these things are in the presence of sources. So there is a j also here. This is also j, and this is a j, and this is also a j. This is what he was saying as introducing a completeness relation plus dot dot dot. This dot 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 basically means is that you are not creating more than one particle. So it's a weak source, very mild perturbation. You are creating only one particle, or you are also destroying one particle. You are not creating more than one particle, no two particles or something like that. So these terms actually denote those terms, and you can neglect these terms. This is gone.
So just let me try to understand this. The final state, that is zero minus, this is with j is equal to zero, right?
Right,
There is
right.
no source.
No.
So I mean, how come initially or there is no source, finally no source? How come intermediate time some source can come up?
So I mean, source
Turn
of
on
purity.
and switch it on.
That is by completeness relation. So it is something.
So you are, I mean,
কমপ্লিটনেস রিলেশন এখানে তো অ্যাসিউম করা হয়ে যাচ্ছে।
Completeness relation assume করার কিছু নেই. Completeness relation is follows mathematically from linear vector spaces. So you have this. What I'm doing is that I'm just inserting an identity here. Completeness মানে হচ্ছে identity. আমি আইডেন্টিটিটা ঢুকিয়েছি। এবার আইডেন্টিটিটা এখানে একটা 0 plus j তে 0 plus j তে প্লাস summation over all q 1qj 1qj প্লাস আবার সামেশন ওভার অল মোমেন্টার, দুটো পার্টিকেল উইথ মোমেন্টার, দুটো পার্টিকেল, এরকম ভাবে পুরো কমপ্লিটনেসটা হবে। কিন্তু আমি এই পার্টটাকে নেগলেক্ট করে দিচ্ছি বিকজ অফ নাও আই এম মেকিং অ্যান অ্যাপ্রক্সিমেশন অর অ্যাসাম্পশন দ্যাট দ্য সোর্স ইজ মাইল্ড অর উইক, দ্য পার্টিশন ইজ উইক। নাও আমাকে সবকটা টার্ম রাখতে হবে।
so it can produce two particles.
এই স্টেপটাতে আমি যদি পুরো টার্মটা রাখতাম তাহলে কোনো অ্যাসাম্পশন নেই। ফিজিক্যাল অ্যাসাম্পশনটা হচ্ছে এই টার্মটাকে যখন ফেলছি এখানে আমি ধরছি যে পার্টিশনটা উইক পার্টিশন। এটাই হচ্ছে আমার এখন এবার ওই লাস্ট লাইনে আমি অ্যাসাম্পশন করেছি। সো লেট আস সি হোয়াট দিস গিভস আস। আমাদের বার করতে হবে কোনটা? আমাদের বার করতে হবে, দেখুন এই 1p 0 plus j মানে এইটাকে বের করতে হবে। এখানে একটা 1p আছে, একটা 0 plus আছে, in the presence of source এ আছে। এইটা this is the required thing that we need to find out, and you can understand from this assumption that এই যে রিলেশনটা, this is of the order of j, right? So this should also be of the order of j, and weak perturbation or mild perturbation, as I've said, that it will create not more than one particles. That actually is equivalent to saying that I will neglect all terms of the order of j square. J square I will drop it out.
Just one more thing. I mean, the source j can create a particle as well as destroy a
So
particle.
it is like a sink. আমরা usually source as sink এ একসাথে source বলছি।
So this I think people should
So,
understand.
source is a generic term for creating as well as destroying
As well as
terms.
destruction.
Particles.
Can we think of the source like, so in a harmonic oscillator, sometimes you have a driving term.
Yes,
which is the
exactly. That is the thing.
Oh, so we can just switch it on, switch it off, and it works like that in the field.
Yes, absolutely.
বলছি লাইক এখানে আবার আরেকটা মোমেন্টামে নতুন পার্টিকেলটা কেন এলো?
এটা কমপ্লিটনেস রিলেশন থেকে এসেছে। কমপ্লিটনেস রিলেশন হচ্ছে এইটা একটা আইডেন্টিটি পুট করেছি। যদি কমপ্লিটনেস রিলেশন ভুলে যাও, যদি আনকমফোর্টেবল লাগে, তাহলে এইভাবে ভাবতে পারো যে ওয়ান পার্টিকেল স্টেটটাকে জিরো পার্টিকেল স্টেটে যেতে গেলে ওটা কিভাবে যেতে পারে। একটা হচ্ছে যেতে পারে ওয়ান পার্টিকেল স্টেটটা একটা ভ্যাকুয়াম স্টেটে যেতে পারে লেট ইনফিনিটিতে, লেট টাইমে, তারপর সেই ভ্যাকুয়াম স্টেট থেকে আবার এখানে চলে যাবে। বা ওয়ান পার্টিকেল স্টেটটা ভ্যাকুয়ামে না গিয়ে একটা ওয়ান পার্টিকেল স্টেটেই যেতে পারতো, কিন্তু সেটা ডিফারেন্ট মোমেন্টাম ফিজিক্যালি টু আন্ডারস্ট্যান্ড। ম্যাথমেটিক্যালি হচ্ছে কমপ্লিটনেস। আর যেটা ফিজিসিস্টরা সবসময় করে থাকে যে এই টার্মগুলোকে ফেলে দিয়েছে।
সাবমিশন কি করে?
অল মোমেন্টামটা যা খুশি হতে পারে, 2 হতে পারে, 3 হতে পারে, 4 হতে পারে, 10 হতে পারে, যা খুশি হতে পারে, সেই সব কটা মোমেন্টামের উপরে তোমাকে সাম করতে হবে।
So even if the source is weak, it can produce a large momentum particle also. Maybe not second particle.
Yes,
So that assumption is there.
that assumption is there. Summation over all Q we have to okay. Can do that, but not more than one. আচ্ছা উইল তোমার আমার টাইমটা দেখো, কারণ আমি আগে শেষ করে দিলে অসুবিধা নেই, আমি পরেরটা লম্বা টানবো। পরেরটা তুমি নেই আমার পিছনে, আমার কোনো চিন্তা নেই।
No, ঠিক আছে. So watch.
So this you have to actually find out. This is the thing that you need to find out. আর আমি বলেছি যে we are neglecting terms of the order of j square, right? Order j square element we shall neglect those terms. So this term you can see this is 0 plus 0 minus at j, at a non-zero j. So this can এটা কত হতে পারে? Question কত হতে পারে? 1 হতে পারে, 0 plus একটা ভ্যাকুয়াম স্টেট আর একটা ভ্যাকুয়াম স্টেট 0
Normalized.
তাহলে 1 হতে পারে 1, but there is a j here, so this can differ from 1 to order j. But so this, what I mean is that this can be 1 minus some order j term, right? But this order j, আর এটা আমি জানি কিছু একটা order j হবে,
We can ignore the
তাহলে order j square, so I can actually neglect this term and say that this is approximately, now our approximation. So this is 1 into what I have is this term 0 plus 1p j is the first term. This is এটাকে আমি approximately 1 করে দিলাম by neglecting the term of order j square. Now look at this term. What is this term? 0 minus 1q 0 minus. The assumption দেখো, এটা কত হবে? এটা দেওয়াই আছে। আর ওটা কি আছে? ওটা জাস্ট এটা কমপ্লেক্স কনজুগেট আছে। So this will be minus I j star q, just এইটাকে ইউজ করলাম, কমপ্লেক্স কনজুগেট দিলাম, এটা সেম জিনিস, কমপ্লেক্স কনজুগেট অফ দ্যাট ওয়ান।
আচ্ছা এই সেকেন্ড টার্মটা j হলো, কারণ এটা তো ওখানে j0 ছিল,
এখানে j0 ছিল, এখানে j আছে, তার মানে পুরো জিনিসটা j তেই আছে, পুরো জিনিসটা j তে, ইট ইজ সোর্সটা আছে, ইট ইজ নট ইন দ্য অ্যাবসেন্স অফ দ্য সোর্স। এবার যেটা আপনি এদিকে লেখেন, এদিকে লেখেন, কিছু এসে যায়।
ও সেইটা
What is this one? 1p 1q
delta PQ.
delta pq, but it can differ j as
One order of j.
order of j, but order j square, so neglected. So this is approximately delta pq, right? Wait on that. So what we have is the following: 0 is equal to or approximately equal to 0 plus 1p j, 1p j, and then plus, let me just write this equation now once more, summation over q minus I j star q multiplied by delta. So this is my final equation, where I have just used this input. This is something remarkable, that you just need to use this input and nothing else. So if you use that, what you will get is the following. This will be 0 plus 1p j, and what will be this? Delta pq summation over q. So you can do the sum. What will this be? Minus I j star p. You take that to the other side of the equation, get this. It's good. Right? So this thing is basically equal to I j star p, which is this.
So এখানে 1q মানে ব্র্যাকেটের মধ্যে 1p
1p.
এটা ডেল্টা p করলে কেন, but there is a source on that side also. In the presence of source you can go from p to q, right?
যা হবে অর্ডার j তে ডিফার করবে।
j square
যা হবে এটা 1p আর 1q আবার অর্থগোনালিটি। যা হবে ডেল্টা pq থেকে অর্ডার j তে ডিফার করবে, কারণ j টাকে যদি আমি সুইচ অফ করে দিই তাহলে ডেল্টা pq পাওয়ার কথা। j = 0 হলে ডেল্টা pq পাওয়ার কথা। তার মানে যেটা হবে সোর্সের প্রেজেন্সে অর্ডার j তে ডিফার করবে। এই অর্ডার j আর এই যে অর্ডার j স্কয়ার ফেলে দিই। Because of
you can write it as delta p.
delta. So mild perturbation. আবার approximation করছি, করলে আপনি এই ইকুয়েশনে চলে আসছেন। Yes.
So when we are saying that this is also mild perturbation, so I know that this is true when we are assuming the completeness, but what are we perturbing here? What are we varying by a small change?
Oh, the perturbation is due to the external source here. You are perturbing. That is
the
why
vacuum is being perturbed.
that is the title of this lecture, right? Schwinger's source theory, disturbing the vacuum. So what you are doing, this is a very good question. What you are disturbing? You are disturbing the vacuum. By what? By the external source. The source is disturbing or perturbing the vacuum. And when it is perturbing the vacuum, in the process, it is creating particles. And if there is a one particle state, when the source acts on the one particle state, it is again doing some perturbation. It is destroying the one particle state. It may destroy the one particle state and give you a no particle state. It may act in a way where it may not destroy the one particle state, but it may give you a new
change the state of the particle.
to a new momentum state. So that is why this is encoded mathematically in the completeness relation.
ভ্যাকুয়ামটা আপনি ডিফাইন করুন।
ভ্যাকুয়ামটা হচ্ছে নো পার্টিকেল স্টেট। আচ্ছা, ভ্যাকুয়ামটা, this is also a good question. So ভ্যাকুয়ামটার মানে হচ্ছে এটা দেখতে পাচ্ছো, এইটা হচ্ছে ভ্যাকুয়াম স্টেট, মানে এটা হচ্ছে একটা কোয়ান্টাম মেকানিক্যাল স্টেট। এই স্টেটটার মানে হচ্ছে there are no particles, কোনো পার্টিকেল নেই এখানে। কিন্তু তুমি যদি এইটা লেখো 0, এই 0 আর এইটার মধ্যে তফাৎ আছে। This is একদম 0. This is completely 0.
Let others also listen.
Okay.
They are not interested in what you are saying.
There is এইটার মানে হচ্ছে এখানে কোনো পার্টিকেল কিছু নেই। There is no quantum mechanical state here. It is completely 0. This has hardly even, there is no physics here. This has a lot of physics. This vacuum state has no particles, but you can show that it has an infinite amount of energy. It has no particles, but it has an infinite amount of energy, which is due to quantum fluctuations. This is called vacuum energy. That is a different question. Just forget about it. And you can actually see the effect of that infinite amount of energy. There is a physical effect which is called the Casimir effect. You can measure it in the lab. Okay, and you can calculate it theoretically. And if you in the calculation of that particular thing, you need to use a very strange result that I'm sure all of you must have seen. It is basically this result. All of you must have seen this result, right? So 1 plus 2 plus 3 going to infinity is basically equal to minus 1 by 12. So if you use this result, you can actually calculate this Casimir effect. This result actually finds it. You need to use this. This was first given by Ramanujan. So anyway, so vacuum is a no particle state, but this is not a vacuum. This has no physics. This is just pure mathematics. This is the number 0 that you require. Okay. So let us now proceed further. We have, with this simple amount of background that we have, we are now in a position to calculate. So let me just write down this result. So what it gives us is the following: 1p j 0 plus is basically equal to I times j star p. You see, I have used complex number. This is jp is a complex number because jx is real. Jx is real, therefore jp must be a complex number. And what's
Fourier transform?
Fourier transform? Fourier transform can leave before. And if you assume this, then or introduce this, I would not say this is an assumption. This is a physical thing that you put in your theory. You will get this. I just leave it as an exercise for all the students to work out that if I started with this, we should be able to show this. So please do that. If you assume this, we should be able to show this. Either way, please do this as an exercise. So now we know about creation of particle. This I know, and I know how to destroy a particle. Creation kothay 0 থেকে 1 particle, and destruction 1 particle থেকে 0. So this is a destruction process or defection process. So I know these two things. What remains to understand is how does particles propagate in space-time? Because that is a very fundamental thing that we need to understand, because in quantum field theory or in particle physics, we need to know how particles interact with each other. Even in astrophysics, you need to know how particles interact with each other or scatter. And for that, you need to know how particles move in space-time. So this is the propagation part from a space-time point x1 to a different space-time point x2. You guys? Good. So
একটু পিছিয়ে যাবো
আপনি একটা প্রশ্ন
এই যে completeness relation as it is written in the form of Kedra summed up being identity, that originates in ordinary quantum mechanics from the fact that any state, arbitrary gate, can be expanded in terms of the eigengates, and from there ultimately we can get to it. But is it the same here?
একদমই same.
Because where are the eigenstates?
Makes a complete set.
এখানেও তাই। এবার অর্ডিনারি কোয়ান্টাম মেকানিক্সে যেটা আপনি বললেন, তো আচ্ছা ঠিক আছে, এটা কি একবার আমি একটু ডাইগ্রেস করছি, ছোট, আমার পরের দিকে অনেক টাইম আছে, আজকে আপনাদের অনেকক্ষণ আমি বসিয়ে রাখবো। ঠিক আছে, আমি একটু ডাইগ্রেশন করছি। আমি আগে স্যারের প্রশ্ন, তারপর তোমার, তুমি আমাকে আবার খেয়াল করি, আমি তোমার প্রশ্ন
এলিমেন্টারি প্রশ্ন জিজ্ঞেস করে
না এলিমেন্টারি না, দিস ইজ অ্যাকচুয়ালি ভেরি ইম্পর্টেন্ট, আমি কেন আপনি এক্ষুনি মানে আপনি যেটা জিজ্ঞেস করেছেন দ্যাট ইজ ভেরি ভেরি ইম্পর্টেন্ট। অর্ডিনারি কোয়ান্টাম মেকানিক্সে আসি আমি। হারমোনিক অসিলেটর, ঠিক আছে? হারমোনিক অসিলেটর মানে আপনার n is equal to 0, গ্রাউন্ড স্টেট আছে, 1 আছে, n is equal to 2 আছে, এবং উঠতে থাকছে। এই স্টেট গুলো অ্যাকচুয়ালি কি স্টেট? এই স্টেট গুলো হচ্ছে এখানে আমরা যেটা অ্যালজেব্রাইক, হ্যাঁ অনেক ছিল। These states are basically energy eigenstates, right? And what you have is some creation operator and annihilation operator. So here we say the terminology is creation and annihilation. But what does it do? It does not create particles. It is, in quantum mechanics, it is not creating any particles, right? What it is doing is that this is the quantum number for a particular energy level. So it is, this A dagger is taking you from this energy level to this energy level, and this A is taking you from this to this. So you are going from one energy state to another energy state, and so on, and also coming down. It is not creating or destroying particles. And there you introduce these kind of states. What does that basically mean? It basically means, since we are familiar with, I could have done it in the other way around, but I shall use the power of the bracket notation. Let me just write down the state gate.
এই জন্য অনেক সময় রেজিং আর লোয়ারিং অপারেটরস বলা হয়।
Raising or lowering operator, I am saying creation or annihilation. This is a misnomer. It is not creating or annihilating particles. It is raising or lowering operators. It is raising between the energy states. Now you take the state gate and let me start from this round. Summation over n summation over n for AB type. So this is equal to identity, this is a completeness relation. Now I just multiply by state ket psi on both sides. So this will be a psi. This is some number which I call an, and therefore I get ket psi is equal to summation over n an ket n, which basically says that these state kets or the energy state, these are the energy eigenkets of the Hamiltonian of the harmonic oscillator. They form a complete set of states in the Hilbert space, right? And therefore, since it forms a complete set of states in the Hilbert space, you can expand any state as a linear combination of this, right? But now in quantum field theory, but here I have not assumed any quantum field theory, but you have some creation or annihilation operators, right? In ordinary quantum field, there you are now. This is a mechanism of creating or destroying particles. So these operators also has to act on some Hilbert space. It is acting on some Hilbert space, and that Hilbert space is actually called a Fock space. Same Hartree-Fock in condensed matter. Fock space. What is that Fock space? Fock space is a occupation number space. It is a vector space or a Hilbert space where you can have zero particle state, vacuum state, one particle state, two particle state, and infinitely many particle states. Since this is a Hilbert space, so it is by definition it is a vector space. Therefore, there is a basis. There is a basis. And what is the basis of that Hilbert space, of that Fock space, which is the occupation number space? It is basically the one particle, two particle, zero particle, all these states. So those states will form a completeness relation just as like this one. And that is what you are inserting here. This is what you are doing.
অর্ডিনারি কোয়ান্টাম মেকানিক্সে যেমন আমি ধরে নিচ্ছি যে স্টেট ভেক্টর গুলো সব হিলবার্ট স্পেসে রয়েছে,
Ordinary
এখানে সেটা একটা অ্যাসাম্পশন, এখানেও সেরকম আমি শুরুতেই একটা অ্যাসাম্পশন করে নিচ্ছি
যে one particle
ফক্স স্পেসে
Fock space, এটা Hilbert space আছে। সেটা আপনাকে করতে হবে, that is quite reasonable.
আন্ডারলাইন একটা
As a mathematical structure, you have to take a mathematical structure, but the mathematical structure is different here. Ordinary quantum mechanics does not give you a mechanism for creating or destroying particles. That was the main problem in hydrogen atom problem, even in Dirac equation, that you do not have any mechanism for creating or annihilating particles. It's a hydrogen spectrum, we see the hydrogen spectrum. You can ask the question, the Lyman series, Palmer series, all these series. What we are solving in class is a hydrogen atom for a single electron. But now you can, in the spectrum, you can see that you have different lines. Now I can ask the question, acha ei photon gulo kotha theke elo? Photon ta to amar theory te chilo na. There was no photons in the theory. So how did the photons come from? Where did the photons come from? You cannot address this question in ordinary quantum mechanics. So you need quantum field theory for that, to address this question. And quantum field theory does that in an amazing way. You can do that. Sir, আপনার প্রশ্ন মোটামুটি
স্পেস টাইম বলতে মানে স্পেস টাইমের প্রপাগেশন হচ্ছে সেটা
স্পেস পার্টিকেল, তুমি তো একটা পার্টিকেল, মানে আমরা পার্টিকেলস হই, তুমি স্পেস টাইম ধরো যাদবপুর থেকে ইউ হ্যাভ কাম টু দিস প্লেস, তো স্পেস টাইমে তুমি এসছো, ঘড়ি আছে, টাইম আছে, আর স্পেস বাসে করে আসছো, স্পেস দিয়ে আসছো, বাইপাস দিয়ে আসছো, স্পেস টাইম পার্টিকেলস হ্যাভ টু প্রপাগেট।
You must have studied special relativity, right? So you must know these things.
actually I got confused.
Okay.
It's fine, you can get confused. These are a little bit. So when I actually talked with Professor Chakraborty, he said that Schwinger theory is mathematically khatamoto. And it is something which is never taught. This is never taught in any place. But this is something which is a research thing. You can, একবার যদি Schwinger-এর বই দেখতে আরম্ভ করো, then you will see that there is a wealth, it's a treasure there, hiding there. So anyway, I'll digress a little bit. I started from 11, so let's check to 15. So let me now, with these two things that I have, these are my two basic results, and you write this also. We are in flat Minkowski space-time. There is a convention here, quantum field theory, like people like us who do quantum field theory, we use this kind of a metric. This is called plus minus minus. Time ta plus, space ta minus. So mostly negative signature. But since I also do gravity te just ulto signature ta use kora, just to confuse people. so that you cannot do gravity. So you get.
So it is an attempt not to allow particle physicists to get into general
No,
relativity.
particle physicists, but there are physicists like us who actually do both the things. So, but that we need to switch signatures. In general relativity, what we do, even for flat Minkowski spacetime, we use this. I'm using this G mu nu, but this is flat, still flat. We use just this convention. এই কনভেনশনটা ইউজ করার জন্য অনেক ইকুয়েশনের স্ট্রাকচার কিন্তু পাল্টে যায়, সবই পাল্টে যাবে, so one needs to be very careful about it. But আজকের ক্লাসে we shall use this signature. This is the particle physicist or quantum field theory signature. Fine. So we have these two things. We have learned about this one, we have learned about this one, creation amplitude, destruction amplitude. We have not learned yet how does particle propagate or come from Jadavpur to the Esenbosch center. We have not learned about that, right? So we need to learn about this. And what we have so far is these two mathematical relations. And for that, this is a consequence of this one. We don't need these two, right? This is a consequence of this one. We have only assumed this and derived this. This is the first derivation that we have done. So the next important thing that we shall want to know is something that I shall write down immediately, and let us see how far we can proceed. So you can now ask the question 0 minus to 1 p. What is the most natural thing that you can ask now? The most natural thing that we can ask now is 0 minus আর কি আছে, কি স্টেট আছে দেখো তো এখানে 0 মাইনাস আছে, 0 প্লাস আছে, আর 1 p আছে, there is 1 p. So 0 minus to 1 p we have assumed, 1 p to 0 plus we have derived. So what is the only other amplitude that we need to know? 0 minus right? This is the only amplitude we need to know now. And what is this? This is something very important. This is how does a no particle state evolve at very early time at t equal to minus infinity, evolve to a no particle state at very late times in the presence of an external source J. This is what we need to know. And this, in normal language, it is called vacuum persistence amplitude. Vacuum persistence amplitude or vacuum to vacuum transition amplitude in the presence of an external source J. Vacuum to vacuum transition amplitude in the presence of an external source J, or vacuum persistence amplitude. Why persistence? Vacuum to persist korche kina? You want to see whether the vacuum persists. So vacuum is persisting to vacuum. So what is the probability of this particular process? And obviously, in the absence of the source, this will be equal to 1, right? Absence of source, this will be equal to 1. In the presence of source, you want to find out what this value is. And I shall just write, this is just a notation, this is no, I just want to introduce it here. This is nothing. I just say that this is basically by definition Zj by Z0. And you see, since in the absence of the source, when J is equal to 0, this is equal to 1, therefore you see that the right hand side is also 1, right? Because in the absence of the source, this is Z0 by Z0, which is equal to 1. Right? This is just a definition. So just the right hand side is a notation. I need to find out what this particular thing is. And we know, so let us try to find this out. This will be a lengthy calculation now. Not very lengthy, but still. So 0 plus 0 minus the presence of source. What do you think this should be? This should be something of the order of something equal to 1. Something equal to 1, because the absence of source, this will be equal to 1. Plus f of j. because this should be obviously dependent on J, right? Because the source is there, it should depend on J. Now, what is this F square bracket J? Again, a bit of digression. What is this? This is a function of a real variable or complex variable, whatever it is. It's a function. See the notation, round bracket. Here it is square bracket. What does that mean? It is basically a functional. This is a functional of what? This F is a functional of the external source J. It's not a function of J, it's a functional of J. What is a functional? You have heard of action in classical mechanics? What is that? Action is L for X. U dt from some initial time to final time, right? So let me just write it down, say 0 to capital T. Is the action functional? This is called action functional. Why is it called the action functional? Because it is not a, this action S is not a function of time T. You can see that? It's not a function of time T. It's very easy to see because this Lagrangian is a function of time T. You are integrating over time T from 0 to T. So this left hand side cannot be a function of time T. Because time has been integrated out. Definite integral. Indefinite hole hote pare. Indefinite integration, it can be a function of time. But action is not an indefinite integral. It is from initial to final time. So this left hand side cannot be a function of t. But what is it? It is a functional of qt. So you write it. Landau Lipschitz, you will see that it is written in this way. Landau Lipschitz book, see it is written in this way. It is a functional of this q. What does that mean? I give you a function qt. This object on the right hand side will give you a number. For any function, it will give me a number. And that number is basically dependent. Obviously, it is dependent on qt. So this action is a functional of q. It's not a function of time t. It is neither a function of q. It's not a function of q. You take a full function, it gives you a number. So a function is a map. Mathematically, a function is a map from a real number to a real number. A functional is a map from a function to a real number. I give you a full function, it gives me a number. It is neither a function of time t, it is neither a function of q. It is a functional of q. Because so now you can understand, see, why should this not be a function of j? Because on this side, this quantity is just a number, right? This quantity is just a number, and this number in this number, it can be some j, p, or something like that, but it can never be a function of x, right? Function of x with the word. Left hand side there is no x here. Okay, so right hand side also there should be no x. So this thing cannot be a function of jx. It has to be a functional of j, so that x has been integrated out.
So essentially, it means that the source can be introduced at any space-time point.
Yes,
From
yes.
minus infinity.
Yes, yes,
That
yes.
is the physical meaning.
Yes, and we shall do that. We shall do that. At any intermediate point, we shall do that. Introduce it. Okay, let me just go. And so our main task is to find this out, what this thing is. And if you can find this thing out, then you will see that you have answered this question. That what is the propagation amplitude? So in order to find this out, I will take this amplitude, this f of j, to be something like this. So let me just write this full thing out. Where did I write this equation? This one. This equation is basically 1. Just forget about this. This is 1 minus half d4 x1 d4 x2 j x2 That is why I just motivated you. Why is this a functional? See, this is a functional of J. Therefore, all these x's have been integrated out. The action functional. See this action functional. So this quantity is a functional of J. And I have assumed that, or this is not an assumption. This functional must be a quadratic functional of J. Quadratic functional of J. Can you say why? Why should it be a quadratic functional of J?
If we vary it with respect to J, we should get a linear like term so that we can get something.
Don't think
analogous.
mathematically, just think physically. Don't think mathematically. The answer key lies in these two equations. See, in going from 0 minus to 0 plus, you can have many, you can go to a one particle state, you can create a particle, but you need to go to a vacuum state. So if you create a particle, you have to destroy that particle. And any creation and destruction of a particle gives you a factor of J. So if you create a particle in some way, this term, there is no creation or annihilation of particle, right? So it is just one. But you can go to a state where from 0 minus, you can go to a one particle state. Now, from 0 particle state to 1 particle state, if you create a particle, that is at a cost of J. But if you create a particle, you must destroy it because your final destination is vacuum. Destruction is also an order of J. So whatever this term is should be a quadratic functional of J. So there should be two J's involved. So you can take that functional to be, and function, since this is a functional, there should be a Jx2, there should be a Jx1, and there should be an integration over x1 and x2.
But you can have processes, I mean, where you produce two particles and
Two
destroy
particle
two-
discuss করছি না।
Oh,
Mild perturbation.
one second.
Sir, why the minus half factor?
For convenience. মাইনাস না নিয়ে করো এক্সারসাইজ হিসেবে, আমি মাইনাস নিয়ে করছি, তুমি প্লাস নিয়ে করো। তুমি বলতে পারো y minus half for convenience. You'll see the convenience in a moment. Okay, I still have 10 minutes or 5 minutes. I will go by this clock. So this half factor, this minus factor, everything is for convenience. তুমি এখানেও বলতে পারতে যে why I here for convenience. It's just for convenience. You put these factors. Okay. So now, what remains?
Just one moment. I mean, here is it an assumption or something that x1, the time corresponding to this, is earlier than time t2?
Early.
There is
না
such
না
thing.
না 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 আসবে early এটা
মানে
আসবে।
টাইম অর্ডারিং তো এখানে রয়েছে।
এরপর টাইম অর্ডারিং নেই কেন? যা x1 x2 যা খুশি হতে পারে, যা খুশি হতে পারে। There is no time ordering, but only thing is that this is a very nice. This f of j should actually I have told you why it should be a quadratic functional of j. So that has been explained. And what about this function? This is basically something like the propagation, as you will see now. This is propagating from x1 to x2, but without any time ordering, as sir was mentioning, without any time ordering. But what I shall assume is that this function sx2 semicolon x1 can be taken to be x2 minus x1.
So this is just a মানে x1 x2 এর একটা ফাংশন দিস আইটেমটা এটা
এটা হচ্ছে x2 আর x1 এর ফাংশন।
মানে এটা ওই ফাংশনালটা মানে অ্যাকশন নয়।
না 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 এসটা না, ওটা মুছে দিই।
হ্যাঁ, এটা আবার অ্যাকশন ভেবে না অবশ্য।
আচ্ছা, অ্যাকশনটা তাহলে অনেক কিছু কিছু বইতে অ্যাকশনটা অ্যাকশন তো
ও আচ্ছা, কার্লি এ করে
ওটার সাথে আবার কিছু ইয়ে হয়ে যেতে পারে, তাহলে এটা এরকম করে দেওয়া যায়।
just tell them that this s is
This
not
S is not action. Obviously not action.
just a function.
This is a function. This is not a function. This is a function. Functionalটা হচ্ছে এই f of j টা, right? And what remains to find out is what is this form? What is the form of this s of s, this function s? We need to find this out. Okay. And before I stop, I would just like to say
That is really the propagation from x1 to x2.
x1 থেকে x2.
So won't it be g?
আমি এখানে g লিখেছি, এটা I will show that this is I have to show something more actually. I assume আমি g ওটা কি g বা কি আমি বলছি না. G is for a special thing that I will come to. G is basically Green's function. But I have to prove that it is a Green's function.
So you take general s, then
Yes,
you will prove
I will prove that that is the Green's function of the field. So everything is coming out from just eta. গ্রিনস ফাংশন সব বেরিয়ে আসে আর কিছু কোনো ফিল্ড কোয়ান্টাম ফিল্ড ফিল্ড ধরতেই হবে
That is coming out from Schwinger's this stuff.
হ্যাঁ from Schwinger is finding all these things of
Great. Fantastic.
now only thing before I stop I would like to say is that this function that I've taken here this is a function x2 semicolon x1 but you can take it to be the difference between x2 and x1 why is this can anyone say why you can take it to be a difference between x2 and x1 because of translational English translation the propagation করতে হবে কিন্তু there is you have to assume this is a physical thing that you assume that there is translational invariance in space and time that is a very reasonable assumption current your experiments should not the results of the experiment should not depend on at what time you start right আমি দুটোর সময় স্টার্ট করি চারটের সময় স্টার্ট করি অভিরূপ স্যারটা একটু ডিফারেন্ট আছে ওটাতে টাইমের সাথে গন্ডগোলের ব্যাপার আছে কিন্তু তুমি হ্যাঁ না কিন্তু তুমি দুটোর সময় ধরো ল্যাবে গেলে একটা এক্সপেরিমেন্ট করলে যা রেজাল্ট পেলে গ্রসলি সেই রেজাল্টটা তুমি যদি রাত 12টার সময় করো রেজাল্টটা পাল্টে যাওয়ার কথা না তাই তো তার মানে there is time translational invariance in your system and time translational invariance আছে মানে it basically means that energy is conserved you can show that mathematically it is Noether's theorem space translational invariance আছে মানে momentum is conserved that is basically a consequence of Noether's theorem right so that is why I can without any loss of generality I can take this function to be depending on the difference between x2 and x1 this is because of translational invariance and also I will assume that this is x2 minus x1 is the same as x1 minus x2 without any loss of generality I can assume that this function s is symmetric mane is a symmetric or even function that is s of minus x is equal to s of x without any loss of generality I can assume this and I can show this but I can show this later but you can actually try yourself say suppose you don't put in this property you should be able to show that this will come out the function has to be symmetric and if you also assume that there is an odd part to it that odd part will drop out so without any loss of generality you can assume that the function is symmetric that is a consequence of mathematics and this is a consequence that it is different depending on the difference between x2 and x1 this is a consequence of physics physics along with mathematics কিন্তু একই ঘটনা একটু ডিফারেন্স আছে এখানে দেখো আমি আরেকটা নোটেশন লেট মি জাস্ট ফিক্স আনাদার নোটেশন p টার আমি 4 momentum I told you 4 momentum this x that I am using here x this is a 4 vector that is mu this is x0 xi I1 2 3 by x vector x0 মানে হচ্ছে t বা ct t equal to 1 মানে এটা t তার মানে x এর মধ্যে একটা টাইম আছে স্পেস টাইম বলছি আমি সব সময় x এর মধ্যে একটা টাইম আছে একটা স্পেস পার্ট আছে তাহলে আমি টাইমটা আগে হতে পারে x2 is basically what x2 0 আর x2 ভেক্টর x1 নিউটা কি x1 0 আর x1 ভেক্টর তাহলে দুটো টাইম আছে একটা x2 0 একটা x1 0 তো স্যার আগে একটা কথা জিজ্ঞেস করছিলেন যে কোন টাইমটা তোমার আগে x1 টা আগে x1 0 টা আগে না x2 0 টা আগে I'm not making any comment about that দুটোই আগে বা পরে হতে পারে মানে বেসিক্যালি এই x2 minus x1 is what is basically x2 0 minus x1 0 x2 vector minus x1 vector right তাই তো 4 ভেক্টরের টার্ম লিখেছি আমি এটাকে ধর একটা নিউ দিয়ে দিলাম এবার তার মানে এই যে জিনিসটা এটা হচ্ছে বেসিক্যালি t2 minus t1 if I call this as t2 and call this as t1 so this is t2 minus t1 but I am not saying whether this t2 minus t1 if I call this as t I am not saying anything about whether this t is greater than 0 or less than 0 it can be both magnitude t but it can be both t can be less than 0 t can be greater than 0 এবার t তার মানে there is a t greater than 0 হলে একরকম হবে t less than 0 হলে and that is called time model. এটা বলে time model. So this is, I think, exactly I'm at 12:50. So let's stop here.
Sir, I have one small question. So a lot of the intermediate steps are very similar to what we do for real scalar fields in quantum field theory. So in quantum mechanics, we have a unitary relation between the Heisenberg and the Schrodinger picture, basically. They are related by a unitary transformation. Does something similar exist for Schwinger theory and the quantum field theory that we do?
See, there is definitely a relation between everything. You can understand the relation from here that, see, I found out, I have assumed this, I have showed this. Now what I am trying to find out is this.
The generating
So
function.
when I have assumed this, I have told you about this. I have derived this from here, so I have told you about this. Now what I want to find out is this. This has this. This is a quadratic functional in J. This is basically S. You need to find out this function S, and this is related to this G.
The green function.
And I have to prove that this is a Green's function. That is the connection. That is not direct connection with quantum field theory still, because Green's function has nothing to do with quantum field theory. But at least what this you will be able to show, or what I shall show, is that this propagation amplitude is basically a Green's function. And why is Green's function important?
That this is S function.
This is, I will show that this is equal to G. This Green's function. S it is
has
not
not
that
been defined
I will just show that S is equal to G. G has to satisfy some property. Then only it will become a Green's function. But that does not mean that there are fields there in the theory. The fields are hidden in all this source business. And you'll be able to show that from this source theory, you will be able to recover the hidden fields inside the theory. And then the connection with quantum field theory will come. Here there is no assumption, or I'm not also assuming that you guys know about quantum field theory. There is no need to know about quantum field theory. This is just ordinary things: special theory of relativity, little bit of quantum mechanics, and little bit of completeness relation. As I pointed out, that when you introduced this completeness relation, this completeness relation that I wrote out, summation over n k and Brian, that completeness relation and the completeness relation that I introduced in this part of the lecture, these two completeness relations mathematically are completeness relations, right? They do the same thing mathematically, but they are different physically. One is the completeness relation about the energy eigenstates, raising or lowering operators, and one is the completeness relation with particle states, whether you have no particle state, one particle state, two particle state, and so on. So they are physically different, mathematically same. Let me stop here. I will continue after that.
Okay,
Thanks so much.
wonderful talk.
প্রশ্ন থাকলে জিজ্ঞেস করতে পারো, কিন্তু আমার অভিরূপের বোধহয় তারা আছে।
ঠিক আছে, তো
তোমার ফ্লাইট করা আছে। এখন কি প্রশ্ন কিছু জিজ্ঞেস করে নেবে না? Because sir, maybe I can address their plans also, or maybe if you have any questions, you can ask.
Students, if you have any question, you can ask.
এই নিজেদের মতো করতে আমাদের হ্যাঁ
আচ্ছা, question এর জন্য করো।
আচ্ছা তাহলে কোথায় কি বল নেই কিছু
Yeah, any question from the students?
ওকে
হ্যাঁ, আচ্ছা, আমরা তো যেহেতু quantum theory জানি না।
এখন জানতে যেও না। কোয়ান্টাম ফিল্ড থিওরি প্রপাগেশনটা জি দিয়ে হয়। ওই জি, আচ্ছা, ফিজিক্যালি প্রপাগেশন ফিজিক্যালি দেখো, কোয়ান্টাম ফিল্ড থিওরিতে প্রপাগেশনটা খুব একটা ইম্পর্টেন্ট না। কোয়ান্টাম ফিল্ড থিওরিতে হোয়াট ইজ ইম্পর্টেন্ট ইজ হাউ টু ক্রিয়েট পার্টিকেলস। তুমি যে অর্ডিনারি কোয়ান্টাম মেকানিক্স শিখেছো, তাতে এখনো পর্যন্ত যেগুলো শিখেছো, তাতে ইউ ডু নট হ্যাভ আ মেকানিজম টু ক্রিয়েট অর ডিস্ট্রয় পার্টিকেলস। সেটা তোমার তুমি জানো না কিভাবে করতে হয়। কোয়ান্টাম ফিল্ড থিওরি গিভস ইউ আ মেকানিজম or gives you a framework to deal with many particles. So quantum field theory কি করে ক্রিয়েট করতে হয় পার্টিকেল আর কি করে ডিস্ট্রয় করতে হয় পার্টিকেল, এইটা তোমাকে বলবে। এবার প্রপাগেট কি করে করবে, যদি থিওরিটা ফ্রি হয়, তুমি যদি একটা ফ্রি পার্টিকেল হও, তোমাকে যদি স্যার না বলে এই এখানে যেও না, ওখানে যেও না, ক্লাসরুম থেকে যেও না, তাহলে তুমি কি করবে? ক্লাস থেকে পালিয়ে যাবে। তো ইউ আর ফ্রি পার্টিকেল। যেরকম ভাবে তোমরা ক্লাস বাঙ্ক করো, মাস্টার্সের ক্লাসে এলে সামনের দিক দিয়ে ঢুকলে পেছন দিক দিয়ে বেরিয়ে চলে গেলে, স্যারও দেখলো না, অ্যাটেন্ডেন্সটা আরেকজন প্রক্সি দিয়ে দিল, বেরিয়ে গেল। তার মানে কি হলো? ফ্রি পার্টিকেল। এবার ধরো স্যার একজন বুদ্ধিমানের মতো কাজ একটা করেছে, এখান দিয়ে পালাবে ওখানে একটা প্রহর লাগিয়ে দিল, একটা পোটেনশিয়াল দিয়ে দিল, তার মানে কি ইন্টারাকশন দিয়ে দিল, আর তুমি পালাতে পারবে না, তার মানে তুমি ফ্রি নাও, তার মানে প্রপাগেটরটা ফ্রি না, তুমি পালাতে পারবে না, তার মানে কি হলো প্রপাগেটরটা এখন রেস্ট্রিক্টেড হয়ে গেল, তো প্রপাগেটরটা এখন চেঞ্জ হয়ে যাবে। So that is what quantum field theory will do. তো তুমি যেরকম থিওরি পুট ইন করবে সেরকম রেজাল্ট পাবে। একটা এক্সটার্নাল এই কোয়ান্টাম ফিল্ড থিওরি ফ্রেমওয়ার্কটা যেটা এখন আমরা করি সেটা হচ্ছে টু ক্রিয়েট এন্ড ডিস্ট্রয় পার্টিকেলস, বাট what Schwinger assumes is something remarkable. He's not assuming any field theory. He's not assuming any quantum field. He's just assuming that you have an external source which is responsible for creating or destroying particles. Yes, obviously.
So we are considering that here as J minus plus
O minus আর 0 minus আমি ওটা বড় করে তোমরা যদি দেখতে পাও 0 minus ওটা ও না
0 minus and 0 plus এর উপরে যে J টা লিখেছি
ওটা হচ্ছে in the presence of source.
আর এটার জন্য যে যেটা জেনারেট হচ্ছে
পার্টিকেল জেনারেট করছে, যেটা আছে বলে পার্টিকেল তৈরি হচ্ছে।
তৈরি হচ্ছে ডিস্ট্রয় হচ্ছে তখন তো ইট ইজ ডিস্টার্বিং দ্য ভ্যাকুয়াম।
আজকে আরেকবার বলো।
যখন পার্টিকেলটা ক্রিয়েট হচ্ছে বা ডিস্ট্রয় হচ্ছে তখনও তো ডিস্টার্ব করছে ভ্যাকুয়ামটা, সেটাকে কনসিডার করছি না।
হ্যাঁ ধরছি আমরা ভ্যাকুয়াম থেকে তো সোর্সটা লেগে পার্টিকেল
myself when Shuman Kumar
আবার যখন ডিস্ট্রয় করছে তখন একটা পার্টিকেল তৈরি হয়েছে, তখন তার সোর্সটা ওয়ান পার্টিকেল স্টেটের উপরে লাগছে না, এই 0 নো পার্টিকেলে লাগছে না, ওয়ান পার্টিকেলে লাগছে, ওয়ান পার্টিকেল থেকে 0 তে নিয়ে যাচ্ছে, তখন ওয়ান পার্টিকেল স্টেটটাকে ডিস্টার্ব করছে। যেটা ভ্যাকুয়ামের উপরে লাগলে ভ্যাকুয়ামকে ডিস্টার্ব করে একটা পার্টিকেল তৈরি করছে, আর একটা পার্টিকেল স্টেটের উপরে লাগলে ও একটা পার্টিকেল যে ডিফারেন্ট মোমেন্টাম তৈরি করতে পারে বা ভ্যাকুয়ামে আবার ডিস্ট্রয় করতে পারে।
আমি বলছিলাম যে ক্রিয়েট হচ্ছে তখনও তো একটা
হ্যাঁ হচ্ছে তো, হ্যাঁ সেটাই তো হচ্ছে, তাহলে মানে অসুবিধা। দ্যাট ইজ আ কমেন্ট, বাট হোয়াট ইজ ইওর কোশ্চেন?
that is what I was asking.
No, that is not a question. That is a comment that you mentioned. What is the question? What is your question?
আমি সেটাই মানে কনফার্ম হচ্ছিলাম যে
মানে তুমি comment করছো এটা। That's correct. Your comment is correct. Absolutely correct.
Your question টা হচ্ছে কমেন্টটা
Comment টা absolutely ঠিক। Comment টা একদম ঠিক।
Endorse comment.